Ciao, this is Liam in for Bear. Your model fires on 18% of patients. What's the chance anyone alert is real? A hospital deploys a sepsis detection model with 90% sensitivity and 82% specificity. The ICU team is told when it fires the patient probably has sepsis. But in a population where sepsis occurs in 2% of admissions, the positive predictive value, the chance the alert is real, is under 10%. 9 out of 10 alerts are false. The model is not broken. The base rate is. This video shows why sensitivity and specificity are not enough, and how Bayes' theorem tells you the number that actually matters. In the terminal, ask Claude to write a Bayes PPV function, then compute a 5x5 grid over prevalence and sensitivity at a fixed specificity of 0.82, the sepsis model's published value, and mark every cell where PPV drops below 10%. Read the key formula before running. PPV equals sensitivity times prevalence divided by sensitivity times prevalence plus 1 minus specificity times 1 minus prevalence. The denominator is where the base rate lies. When prevalence is 0.005, 0.5%, that denominator is dominated by the false positive rate, and sensitivity can't save you. Run it. The heat map shows 25 cells, prevalence on rows, sensitivity on columns. The top 2 rows, prevalence under 1%, are entirely crimson. Every cell is below 10% PPV, regardless of how high sensitivity goes. The gold band in rows 3 and 4 is the transition zone. Only when prevalence reaches 10% do you start seeing green, and even then. PPV tops out at 35% with 99% sensitivity. The grid is the audit. Now iterate. Ask Claude to add a specificity sweep, hold sensitivity at 90%, vary specificity from 0.7 to 0.99, and show at what specificity the PPV at 2% prevalence finally crosses the 10% threshold. At 2% prevalence with 90% sensitivity, you need a specificity of 94% before PPV clears 10%. The sepsis model published at 82% never makes it. The lesson: sensitivity and specificity are properties of the test. PPV is a property of the deployment context. They are not interchangeable, and the base rate is not optional information. Your move: find the base rate of the condition your model detects in the real deployment population, not the training set. Plug it into the Bayes PPV formula with the published sensitivity and specificity. If PPV is under 20%, your alert system needs a prevalence-enriched pre-filter before it goes clinical. The complete source is in the video description. Fork it, swap in your own data, and see what you find. If your numbers break the pattern, that is the interesting result. Let's recap with Claude. A hospital deploys a sepsis detection model with 90% sensitivity and 82% specificity. The model is not broken. The base rate is. Your turn. I'm studying base rate Bayes calculator. Why high sensitivity isn't enough using Claude CLI. I understand a hospital deploys a sepsis detection model with 90% sensitivity and paste this into Claude. I want a sensitivity equals 90%, PPV equals 9%, the base rate gap. Walk me through 1. How to set up the script. 2. How to run it and verify the output. 3. How to interpret the result. Base rate Bayes calculator. Why high sensitivity isn't enough. I'm Liam in for Bear.